Yeah, good afternoon, everybody. The title of my talk gives it all away. In the next couple of minutes, I will talk about how it is possible to deactivate endpoint protection software in an unauthorized manner. And actually, I will talk about two less regarded security issues that we find occasionally in this kind of software, but also in other software products. Some information about me. My name is Matthias Deeg. I'm interested in IT security since a very long time. I've studied computer science at the University of Ulm, and since 2007 I work as an IT security consultant for a small IT security company in Germany called SYS. The agenda of my talk is this. At first, I want to introduce what endpoint protection software actually is and what's its role in IT security. Then I want to talk about the two less regarded security issues that my colleague and I have actually found again in the beginning of 2015. Then I want to talk about some use cases and attack scenarios regarding these less regarded security issues and how they may be exploited. Then I hope that I can show you a live demo, and afterwards there are some conclusions and recommendations, and I think there will be plenty of time for Q&A. So when I talk about endpoint security software in this talk, I think of something like this, as you can see here in this picture. So endpoint protection software is actually software that is running with higher privileges on endpoint systems. When I talk of endpoints, I mainly mean client systems in computer networks or server systems. And the purpose of this kind of software actually is to prevent attacks running against your endpoints that you have in your corporate network, for example, or your government network. So generally speaking, endpoint protection software is just one type of security control to protect IT systems, as I already mentioned, for example, client or server systems from different threats and the corresponding IT security risks. Typical features of endpoint protection software products are antivirus and malware detection. So the classic antivirus software that's running on client and server systems is a type of endpoint protection software, but endpoint protection software nowadays also has many more features than only antivirus or malware detection. There's, for example, application control. So you can do application whitelisting, where you can define that only specific application or software is allowed to actually run on a specific client or server system. You can also do device control. So, for example, you can control the use of USB devices. One popular example are USB mass storage devices, so that you cannot simply stick in a USB flash drive, copy all the contents of the hard disk and take it away, so data exfiltration, stuff like that. Or another popular device control issue is still FireWire. So all the devices still have a FireWire built in, or you can extend the FireWire devices by PCMCIA or ExpressCard, and there are still some attack scenarios where you can use FireWire rather well. And endpoint protection software also has firewall functionality built in most of the products in order to protect your system from network-based attacks, or to contain an ongoing attack that just started on your client system, and you want the malware to contain on the system it's currently running and prevent network communication to other systems that it just cannot spread that easily, for example. Okay, and what my talk is mainly about is the password protection feature of some endpoint protection software products. And password-based protection is actually implemented to set restrictions on different management functionalities or all features that are provided by endpoint protection software. And this protection is implemented in order to reduce the risk of unauthorized or unintended changes in the functioning of the endpoint protection software. So if you think of a corporate network, you don't want everybody to change the firewall rules on endpoint or antivirus updates or stuff like that, and that's what the password protection is actually for. And yeah, restricting administrative access generally is a good idea, especially when it comes to security, because when everybody can change anything on a system, well, there mostly is no security at all. And in order to access and use protected management functionalities of endpoint protection software products, you usually need a password. So what we have here are password-based authentications because they are the most simplest to implement, and the most manufacturers of this kind of software do it this way. And in this talk, I will present software products of 3 different vendors, Kaspersky, Panda, and Bullguard, where we have found some security issues. Yeah, and here's an example of Kaspersky Endpoint Security 10 and the password-based protection and how you can change the settings and either protect all operations or selectively only some of the operations. And this protection should prevent, as mentioned before, unintended or unauthorized changes to the software at all. Yeah, and now I want to talk about 2 less regarded security issues. Yeah, the security vulnerabilities I will present here are not big ones, so it's no remote code execution from anywhere on the world, but locally exploitable security issues. And that's why they are less regarded, but in my opinion, they should get more attention, because in some attack scenarios, the exploitability of these less regarded security issues make the difference. And the 2 less regarded security issues I want to talk about are first, authentication bypass vulnerabilities, and second, the insufficient protection of user credentials. And concerning authentication bypass vulnerabilities, I especially talk about local attack scenarios in non-network software features. For example, the management of locally installed software products, like in this case for the endpoint protection software. But you can also think of locally exploitable authentication bypass vulnerabilities in other products, namely every application that has an offline database. So one popular example are password safes or password vaults, where you have a synchronized database locally. And if there are any issues concerning the authentication, yeah, it actually is a critical security issue. Yeah, and the second security issue I want to talk about is insufficient protection of user credentials, and there are actually many ways you can insufficiently protect user credentials in software. For example, storing them as clear text passwords. That's not recommended for obvious reasons. Or you can use cryptographically weak one-way hash functions without a salt, because this also helps an attacker in some attack scenarios to profit from an exploitable condition. Or the use of symmetric cryptographic ciphers with a single hard-coded key for all installations. So yeah, if the manufacturer has only one symmetric cryptography implemented, or only one cipher implemented in his products, and he uses one key for all installations all over the world, an attacker has to do the work one time, and he can exploit this security issue every time he sees it. And once there is a tool available on the internet, an attacker don't even has to have the capabilities to do the analyze by himself. He just uses readily available software and exploits it. And another common issue concerning insufficient protection of credentials are world-readable password information. This means that concerning IT system, for example, a client system, everybody who has access to this system is able to read the password information, no matter if it's clear text or it's encrypted or obfuscated in any way. But that's also a security issue. Okay, so now some details about the authentication bypass vulnerability in this talk. An authentication bypass vulnerability allows an attacker to access and use functionality of a system without completing a required authentication step in the intended way of the actual programmer or the manufacturer. So concerning password-based authentication mechanisms, being able to use an arbitrary password, for example, or no password at all in order to log into a system is a classic example of this vulnerability type. And there are different root causes for this vulnerability type. For instance, improper input validation, so for example, SQL injection vulnerabilities, or more general, the violation of secure design principles. And for the latter, I have an example here. And yeah, on this slide, there's a security problem we have found in different endpoint protection software products, but it's also in many other products, actually, and it's exploitable if you have local access to the low-privileged domain on the left. So I will shortly explain the scenario here, what's shown on the slide. We have actually two processes, one on the left, here named product service, running with high user privileges in a high privileged domain, as I've called it, and on the right, you have a low-privileged user process here called product UI. So it's for the user interface shown to the user, and this process is running in a low privileged domain with low privileges. So what the service process does is it performs tasks with high privileges, for example, change the configuration of the product, enable features of the product, or disable features of the product. And what the low privileged process does is it shows status information to the end user, it handles user interaction, for example, the UI stuff, and in some cases, it also does user authentication. And that's an obvious one. That's a security problem you can exploit in many scenarios. And that's actually a violation of secure design principles if you do stuff like that in low privileged domain that just does not belong there. So if authentication is done within a process that runs or can be run in the context of a low privileged user, it can be analyzed and in most cases also manipulated by a low privileged user. And in order to bypass an authentication mechanism, an attacker only has to modify the corresponding authentication check so that it always returns true, for example, by comparing the correct password with itself, or just by modifying the control flow of the actual program. And the consequence of this is that protected features can be used in an unauthorized way in case of the endpoint protection software, as we will see later. So here it is what it looks in Oli debug during runtime concerning the example Kaspersky Endpoint Security 10. And I have a close-up of this. So what's the interesting part and actually the vulnerability Kaspersky made in this scenario? Well, I already said the password comparison is done within a process running with the context of a low privileged user. The process is called AVP in this case. And as we can see here, it's just a default string compare routine that is used. And what is actually compared in the case of Kaspersky, or all Kaspersky products I've tested, is two MD5 hash values, actually raw unsalted MD5 hash values in this case. And concerning Kaspersky products, the MD5 hash value was generated for a string that was UTF-16 little endian encoded, actually without the terminating null byte. So just some technical details. This is important, for example, if someone wants to check the complexity of the passwords and wants to see if the password in use in this scenario, for example, for protecting the management functionality, is in compliance with the corporate password policy. At least that is something I actually do when doing security assessments, and there are also interesting findings. And the next vulnerability, that's also less regarded and underestimated, is the insufficient protection of user credentials, and this can also be exploited in different ways. And one example was actually using MD5 hash values unsalted. So if a low privileged user has access to password information that are not required to perform her task or his task, it is usually a security issue, because we're violating the principle of least privilege. And furthermore, if the accessible user credentials are only protected in insufficient way, it definitely is a security issue, because then the user or attacker of malware actually may benefit from the access and recover password information, for example, or do pass the hash attacks or whatever is suitable in different scenarios. And in case of the Tesla endpoint protection software products, I will talk about here. Password information was both accessible by low privileged users, and it was also insufficiently protected. And the consequences of this is that protected features can be used in an unauthorized way. And here again the example of Kaspersky Enterprise Security 10. But this is true for all the tested Kaspersky endpoint protection products. In this case, the password was stored as raw unsolved MD5 hash value in the Windows registry. Here you can see the actual registry value where you can read it. The registry key is by default readable by every user, so you don't have to have administrative rights or something like that. So everybody just can look in the registry if he is able to open Regedit or something like that, and extract this information, perform an offline attack at home or using a cracking cluster at his disposal. And if he's able to crack the password, he can also attack the password-based authentication and manage the endpoint protection software and all its features in an unauthorized way. But that's the hard way to do. It's even more easier, as we will see in a few minutes. The next thing is that the MD5 hash can also be extracted as a low-privileged user from the memory of the process AVP during runtime. So there is not only the possibility to perform a so-called offline attack, where you just extract the information, take it home, or give it someone else, put it in the cloud, do some password guessing attacks. You can also extract information directly from the memory. But in this case, from Kaspersky, it is still hashed, so you have to do a secondary attack, a password guessing attack, but we will see later on that sometimes you will get information that you can directly use for further attack scenarios. And generally the use of cryptographic one-way hash functions that are cryptographically weak, like MD5, actually, when used without assault, allows an attacker to perform rather efficient password guessing attacks using pre-computed dictionaries, for example, rainbow tables. MD5 can also be calculated rather fast on modern CPUs and GPUs. So using MD5 today is not recommended anymore. And here's the example, a screenshot from the registry editor. For Kaspersky, in this case, we have the registry value OPEP, and what's stored in there, it's just an MD5 hash value unsalted that you can give your favorite cracking tool, John the Ripper, Hashcat, or whatever you like. Okay, so what are the actual use cases and attack scenarios concerning these less regarded security issues? Well, I came up with actually two. The first use case is bad guys doing bad things for fun and profit, and the next one is good guys doing bad things with permission for fun and profit. For example, pen testers like me, or IT security consultants, but the main thing is, in both cases, bad things are done, and actually you want to avoid bad things when it comes to your corporate network, the systems you're responsible for. So it is good if these vulnerabilities will vanish in the future. But actually they seem to prevail, and we find them actually once in a while, so every 2 or 3 years, the same thing, just in a different product. And what are the attack scenarios? One is that a low-privileged user disables features of the endpoint protection software just in order to perform malicious actions. So think of an insider attack. You have somebody in your company who has regular access to IT systems. The IT system is centrally managed, and there's endpoint protection software in place to avoid different kinds of threats. And the attacker is able to simply disable your endpoint protection software with a mouse click, and then can perform his malicious actions, and you don't see anything of it if everything goes the worst way. And the second scenario is you don't have an actual user, but you have malware that is executed in the context of a low-privileged user within your corporate network. And yeah, this malware can do actually the same as an interactive user clicking on the mouse or typing some keys on a keyboard. And malware can actually also just deactivate your endpoint protection software in an unauthorized manner and then perform further malicious tasks without any intervention from the security control in form of the endpoint protection software. Yeah, and here is a real-world example from my day-to-day work as pen tester. So during security assessments, endpoint protection software can be really annoying for me and all my colleagues, and sometimes it can also be a showstopper, because if we are able to gather credentials by other means, and we are able to access systems, it is just not enough when launching attacks. And state some point. Because the successful login is not a guarantee that you can also extract or exfiltrate interesting information by using interesting tools. So the profit for an attacker, also for me as a pen tester, is rather limited. So sometimes I just cannot take the next step or take the next hop in a network because endpoint protection is stopping me. And that's what it's for, actually. That's a good thing. But because of these less regarded security issues, malware or an attacker is able to just deactivate endpoint protection software features rather simply, and then continue with his malicious tasks. And of course, there's also antivirus evasion techniques, but antivirus evasion can be rather tricky and time-consuming, and I think that deactivating security features completely or selectively, as I want, can save precious time. So, concerning the password protection management functionality, it is also interesting to see, as I already mentioned, if the used passwords are compliant to given password policies. For example, in a company I do security assessment for. And one observed result is that in most cases the used passwords to protect these administrative management features are non-compliant with other active password policies, for example, that are active in the Windows Active Directory environments. So actually the passwords used to protect administrative features are much weaker than the default passwords that are required by every user in the corporate network. And that's, I think, rather interesting and observed very often by me and my colleagues. Okay, and in this table you can see some of the affected endpoint protection software products my colleagues Sven Freund and I have tested in the beginning of 2015. And these are the example we have published security advisories for, but this list is nothing but complete. So there are also products of other vendors that have the same less regarded security issues and that are just exploitable in the same way. Okay, and what we have actually done is we have written some proof of concept tools for all of the affected software products I've just shown in the table before. And I just want to demonstrate the security issue in a live demo, hopefully. With the example of Kaspersky Enterprise Security, and here we have written a tool named Unload Cas. And these proof of concept software tool is simply a loader technically with some patching functionality, and it works as follows, following these 4 steps. At first it finds an executable file called AVP in the file system. Then it just creates a new instance of the process AVP with a specific command line argument. In the example I will show, it's the exit function that is triggered, and the exit functions just shuts down the endpoint protection completely. The next step is to patch the password-based authentication of the newly created process so that any password is considered correct, or actually that no more password is required in order to trigger this functionality. And the last step is to stop debugging the process and continue its execution normally. So yeah, on this slide and the next slide, I've shown the most important parts of the source code of the proof of concept software tool, and what the C source code does is just the 4 steps I just mentioned before. So find the executable file, the module, create a new process. This proof of concept software tool is implemented as a user level debugger, if you want to have it that way. So we make use of the Windows debug AP functionality in order to patch the target process during runtime and do whatever we want. Because there's a debug loop and that's a simple thing to do. Here we apply the patch if it is possible and close the handle to the process and let the process continue its work. Okay, so now I will try to show a live demo concerning enterprise security, Kaspersky enterprise endpoint security, excuse me. Okay, but what I want to show you first, it's not a full screen, I think it doesn't matter. What I want to show you first is the actual target of the exploit, because that's a command line tool in case of all the Kaspersky products. I need my hands. Test, 1, 2, okay, fine. Okay, so in case of all the Kaspersky products we have tested, we are always targeting this executable here, or actually the process during runtime, when we started as a low privileged user. And when I just started from the command line, evp-exe, you will see, the GUI is showing up. But you can also do some further investigations, and you can see that there are also command line arguments for different operations you can actually do or trigger from or via this tool. And what I will show you here is the exit product function. Honestly, I did not have a look at all the other features, but they also may be interesting for other kind of attacks, because you can also import settings and maybe trigger other unwanted behavior in corporate networks. But I will just show how you can deactivate or disable the endpoint protection completely in this case. Okay, so as you can see, I'm running endpoint security 10 in this case on Windows 7. Here's the icon, here's the GUI, and we can also have a look at my privileges. So, it's a German Windows, but the user I'm currently logged in as is only a default limited Windows user, member of the group users. And when we have a look at the Windows services running, there should be something from Kaspersky. Yeah, right here, the Kaspersky endpoint security service is running. So that's the thing running with high privileges in a high privilege domain. And for example, the GUI we have here is low running in the context of my user. And also if I run the AVP executable here, that's the wrong directory. And also if I run this executable here, it's also running in the context of my low privileged user. Okay, so I just want to demonstrate quickly our proof of concept software tool. It's actually a command line tool called unload cas in this example. And we see here Kaspersky is still running. I press enter. some windows are popping up. Here we have the output of our tool. And if we look here, Kaspersky is gone, at least the GUI. And if we have a look at the started services, there shouldn't be any Kaspersky service anymore. No, it's still here. Auto protection should be deactivated. Okay. Yeah, I just ran it once again because you cannot find it anymore. Okay. Oh, it's still running, but it shouldn't have any protection features anymore. I will start it again. And what I've prepared to show another scenario that is more realistic and still works today in 2015 is a scenario using malware distributed via Microsoft documents containing active code. And what I've prepared here is just a simple Trojan horse containing a payload that automatically deactivates the endpoint protection software and afterwards starts arbitrary code. It does not start automatically because my system uses default settings concerning macro security for Microsoft Office, and I have to activate it as user manually. But during our security assessments, when we do targeted attacks, we often found that users, if they are presented with a correct or an interesting Word document, they are rather willing to activate active content contained in the document, and then actually bad things may happen. So what we should see now is that Kaspersky is gone again. We should have some messages from here that we should reactivate Kaspersky endpoint security, so some Windows messages. And what I've programmed here is just a proof of concept malware, if you want, so that just says that if you can read this message, it's already too late, because at this point, an attacker of malware actually has arbitrary code execution with the privileges of the currently logged in user. Okay, so this was just a quick demo concerning Kaspersky products. And I have the same as backup here in the slides. So here's the password protected features. So actually, if you want to use the command line interface, you can set a password also via command line parameter password, or you are interactively prompted with a password prompt. But what I did in the proof of concepts of the tool is I just changed the control flow in such a way that we never will reach this password prompt, and it just deactivates, for example, the endpoint protection using the exit function or stops the scan or whatever you want in an unauthorized way. Okay, and this was just the output of the proof of concept software tool following the 4 steps I mentioned earlier. And the same is also true for other products, for example, of the manufacturer Panda. Works in the same way, but here's an interesting difference because concerning the Panda software products we've tested, we were able to also extract the correct password he's actually asking for from the memory. So here they don't even use hashing, cryptographically one-way hashes to protect credentials that are intended to protect administrative management features, but they just made the password available in a low-privileged user context in clear text. And the same is also true for the Bulgari products we have tested. You can also just patch the password-based authentication as a low-privileged user, as malware, and bypass it in that way, and you can also extract the correct password as plain text. So here, both less regarded security issues I've mentioned earlier On the one side, authentication bypass. On the other side, insufficiently protected credentials could be found in these endpoint protection software products, and can actually be used to deactivate security features in an unauthorized manner. Okay, so the conclusion is that this kind of attack is actually possible. My colleagues and I actually do it most of the time when we are doing security assessments of client systems for our customers. It's no new issue. It's rather old actually, but as I mentioned before, it pops up every couple of months of products we analyze. And in this case, it was in the beginning of 2015 concerning Kaspersky, and we had a look at other products. And I also know of some more products that are affected by these vulnerabilities, but I cannot talk about it. And security issues like authentication bypass, vulnerabilities concerning local attack scenarios should, in my opinion, also get more attention, because in some attack scenarios, they are a crucial step to cause more damage. Because if I'm able to deactivate an endpoint protection software and I was able to get login information from some other source, I can log into a system, deactivate all protection features, upload some interesting hacking tools, for example, Mimicuts or Windows Credentials Editor, dump credentials in Windows Active Directories, and take over complete Active Directory environments, for example. Okay, and another conclusion is that any security-related task should, if possible, performed in a more trustworthy environment. So not in low privileged user processes where actual malware has access to, or even attacker or malicious users have access to. And coming back to this illustration here, a good idea is just to do user authentication and other high privileged or other sensitive tasks in a high privileged user domain in this way. Okay, and here are some general recommendations for people developing software like that, or generally speaking, for all IT security systems. Always consider trust in IT security, because oftentimes IT security is just a matter of trust. So you have to know your trust domains, your trust boundaries, your trust relationships. Another recommendation is do not assume too much, because if you have too many assumptions about an IT system or the execution environment of a specific software component, in reality, there are many assumptions that just don't hold true, and your product may be vulnerable to specific attacks. And another general recommendation is properly protect your password information. Mainly restrict access to password information, whether clear text, hashed, encrypted, whatever, to required users only. Use cryptographically secure standard algorithms with a suitable configuration. So my recommendation here is the password-based key derivation function 2 with up-to-date one-way hash algorithm, many rounds, that just makes it very hard for an attacker who has access to hashed password information to recover clear text passwords. And it's also a good idea in general to follow the principle of least privilege. I know it's hard sometimes, but I think it's worth the effort. Okay, here are some references. The first is a paper from 2012. It's just about the same topic. Back then I found the same kind of vulnerabilities, less regarded vulnerabilities in Office Scan of Trend Micro. So Office Scan was back then also rather easily deactivatable without any further privileges in an unauthorized way. And there are some security advisories we've released this year concerning the software products, the endpoint protection software products from the manufacturers Bulgard, Panda Security, and Kaspersky. Okay, and that's it. Thank you very much for your attentions. And now I think we still have some time for Q&A.
Okay, we have some time for questions.
I have some questions, yes. You talked about this low privilege process, which is controlling a high privilege process. I mean, it's by default is not secure. So any product which uses this construction to control security features should not be accepted anyway.
That's right, but
and it's not only about user identification. I mean, everything you can control with the.
Yeah, that's right. But that's one of the assumptions that some developers make that just don't hold true in reality when somebody has a closer look, or maybe just these issues are overlooked. Yeah. But you can find this kind of design principle or violation of security design principles actually in rather many software products.
Then I have an afterburner. And what do you have any positive examples or products which you can say they don't fail at that principles?
Nothing I could talk about. I fear. Yeah. There are software products that do it the correct way, where you, for example, have to elevate the privileges of your Windows user.
That's what I mean, yeah.
Yeah, and that's one other way to do it correctly. Yeah, but I just cannot mention the product right here. Yeah.
Any more questions? Then I have a question.
There's one other question in the back.
There? Ah, sorry.
Great talk, thanks. Did you experience centrally managed AV products? They are talking to central servers.
Excuse me, I didn't.
You talked about locally managed AV
Yes.
products.
Okay. Well, in the research we did, or the security assessments, actually, we just had a look at the local authentication features. But you're right, there are also centrally managed endpoint protection software products that do the authentication on the server side, for example, but we don't had a look at these features up to now. Yeah.
Why I'm asking is, aren't there any alerts if you deactivate or disable on the server side, if you do that on the local?
Sometimes there are, yeah, sure. But then it's a matter of how the people are reacting to these kinds of alarms. And actually, in the case of malware, if you just temporarily disable the security control, do your malicious things, exfiltrate the data, the alarm afterwards, you just don't care. If you have the data exfiltrated, the damage is done. Yeah.
Pentest is over.
Yeah, sad but true.
Thanks.
Further questions? One question from me. I think companies like Kaspersky should know better. So the question remains, yes, there is a saying you shouldn't attribute to malice what can readily be explained with stupidity, but they should know better. What's your explanation for that?
Actually, I don't know. It's, well, security costs money, and I think that's the main explanation for me, that we just see the same security vulnerabilities over and over again.
Because as a company like Kaspersky, where you have installed software which is privileged on a high percentage of the world's computers, it's definitely, I'm not into
but
conspiracy theories, but
And another problem is, as I mentioned in this talk, the security issues I've presented here, they are regarded less, or they are less regarded for a reason because the attack scenarios are rather limited. And Kaspersky, if you follow the news, they also have other security issues they should fix first before. Yeah, they should fix all security issues. And actually, they have fixed these issues. We've reported issues in February this year, I think, or March, and they were fixed by October. But they also have other security issues, the big ones, remote code execution, that have also been reported in the last couple of weeks. Yeah, but I don't have an explanation why the software quality actually concerning security features is rather low.
Especially from a security company.
Yeah, especially from security companies. Yeah.
Okay. Further questions? Then maybe further discussion offline, and thank you for the talk.